talking about the kind of the loads are on the building. So there will be external load. External loads on the structure may be classified in several different ways. In the one classification, they may be considered as a static or the dynamic load. So all the external load can be either as a static or the dynamic load. Static loads are force that are applied slowly and then remains nearly constant. So that there's a weight of the building is a dead load or flow of the roof system. Those are the static load. And dynamic load will vary with the die. So it will be there. They include a splitted and the embed load. So embed loads are the dynamic loads. Repeated loads are the force that are applied a number of the die. So when the force is applied a number of the die, the load will be the repeated load. The constant is a variation in the magnitude and sometimes also in the sense of the internal forces. So those are the repeated load. A good example of this of the balance motor. So of balance motor is the way the repeated load. So embed loads are the force that requires a structure or its component to absorb the energy in a short interval of the die. So all the embed loads are the force that require the structure or the components to absorb the energy in the short interval of the die. For example, the drawing of the heavy weight on the floor slab, that will be the embed load, or the short weight from the explosion striking the wall at the roof of the building. So this is also the embed loads. External force may also be classified as a distributed and concentrated load. So external force can be either be distributed and the concentrated loads. Now we're talking about the uniformly distributed loads. They are the force that are for the practical purpose and may be considered constant over the surface area of the supporting member. So that those are uniformly distributed load. They are may be constant over the surface area and of the supporting member. So that weight of the row steel beam is a good example of the uniformly distributed load. Another one with the concentrated loads, they are the forces that have such small contact area. So they all the contact area, small area. So that will be the concentrated load. And negligible areas, this area can be negligible compared with the entire surface area, the supporting member. So the load area, impact area, is negligible by comparing the entire surface area of the member. So that kind of load is a concentrated load. A beam support is a gather may be considered for the all practical purpose is a concentrated load on the gather. The another classification for the external force lever, there can be the axial or eccentric and the torsional. So those are the kind of the concentrated load. And axial load is a force whose resultant pass through the centroid of the section under the consideration and perpendicular to the plane of the section. So axial load will be this is the force and resultant pass through the centroid of the section under consideration and perpendicular to plane of a section. So this is axial load. Eccentric load is a force perpendicular to the plane of the section under consideration, but not passing through the centroid of the section. And the bending of the supporting member. So there will be the bending of the supporting member can be the eccentric load. Torsion loads are the force that are the offset from the shear center of the section under consideration are inclined to or in the plane of the section, that's a twisting. So twisting load are also there, the torsional flows. Also the bearing codes are classified and load across them with the nature and the source. And that load include the material, equipment, construction, other elements of the weight supported by the bearing, including all weight that are the idea to remain permanently in place. Two kinds of the loads are there in the permanently in the place. There will be the dead loads. Live loads include the all occupied material, equipment, construction, other elements of the weight, and they are the bearings that will be likely to be moved. So that we say live loads. Embed loads are the fraction of the live loads used to account for additional stresses. So this is the deflection resulting in the moment of the live loads. They are embed loads. Wind loads are the maximum force that may apply to the bearing by wind. In the main side, this is the winds are loads are will be there, wind loads. And snow loads are maximum force that may apply by snow, accumulation of snow, and symmetric load with the forces that produce the maximum stresses or the deformation in the bearing or during the arcways to a symmetric load. So those are the kind of the variant loads. Those loads are adding on to the bearing. ခုတင်ပြမှာတော့ပြင်ပလုပ်တွေဖြစ်တဲ့ external လုပ်တွေဖြစ်တယ်အဲ့တော့ external လုပ်တွေကိုတော့အမျိုးမျိုးခွဲခြားနိုင်တယ်ပထမဦးဆုံးတော့ static လုပ်ဆိုတာအမိုးတွေနော်နောက်တစ်ခါနော်ဒီလိုကြမ်းပြင်တွေအဲ့ဒါတွေကဆိုရင် static လုပ်လို့ခေါ်တယ် dynamic လုပ်ကတော့ရုပ်တရက်ကြောက်တဲ့ဝန်တွေကိုတော့ dynamic လုပ်လို့ခေါ်တယ်repeated လုပ်ဆိုတော့အချိန်ပါများစွာတက်ရောက်နေတဲ့လုပ်တွေဖြစ်တယ်အဲ့ဒါဆိုရင်တော့ repeated လုပ်လို့ခေါ်တယ်အချိန်ပါများစွာကြားနေတဲ့ဝန်တွေဖြစ်တယ်ဥပမာဖြင့် mortar ဆိုရင်တော့ repeated လုပ် impact လုပ်ကတော့ချက်ချင်းကိုတော့ကြားလိုက်တဲ့ heavy weight ဟောအဲ့ flow set တွေပါတွေအဲ့ကိုချက်ချင်းကြားလိုက်တဲ့နော်ဒီမှာ flow set တွေကနေပြုတ်ကျသွားတယ်ပြကျ heavy weight က weight လေးတဲ့နော်တုံးတစ်ခုကနေကြားမြကျသွားတယ်ဆိုရင်အဲ့ဒီမှာနော်အဆောက်အဦရဲ့နော်နိုင်ရန်ဒီအမိုးတွေပါတုံလှုပ်သွားတယ်အဲ့ဒါဆို impact လုပ်လို့ခေါ်တယ်ဒါကြောင့်မလို့အဲ့ဒီစာနော်အပြင်ပကနေတက်ရောက်တဲ့အားတွေကိုနော်သူကဖြန့်ထားတဲ့အားနဲ့နော်ဒီနေရာမှာစုစည်းထားတဲ့အား distributed နဲ့ concentrated ဆိုပြီးတော့နှစ်မျိုးနော်ခွဲလို့ရတယ်အဲ့တော့ uniformly distributed လို့ဆိုတာတော့ညီမျှတာခွဲပြီးတော့ဖြန့်ထားတဲ့ဝန်တွေဖြစ်တယ်ဥပမာအဖြစ်နော်ဒီလိုရက်မတွေရာဆိုရင်နော်ညီမျှတာခွဲပြီးဖြန့်ထားတဲ့ဝန်ကိုထမ်းဆောင်နေတာဖြစ်တယ်concentrated လို့ကတော့ကျင်းမြောင်းတဲ့ area ကိုပဲအားပြုပြီးကြာရောက်နေတဲ့နော်ဝန်တွေကြတော့ concentrate လို့ခေါ်တယ်extra ဘုတ်ကတော့ဒီလိုဝန်ရိုးတစ်ချောင်းဆွဲထားတဲ့ဝန်တွေeccentric လို့ကတော့ဝန်ရိုးလိုတောက်ပံကြားတဲ့ဝန်အဲ့ဒါကြောင့် eccentric လို့ဆိုတာဆိုရင်ဒါ extra လို့ဆိုတာဒီသူကနော်ဝန်ရိုးတစ်ချောင်းဖြစ်တဲ့အတွက်သူကနော်အလျားတူသွားတာကိုရှည်ထွက်လာတော့ဖြစ်နိုင်တဲ့ eccentric လို့တော့ဝန်ရိုးနဲ့တောက်ပံကြားနေတဲ့ဝန်တွေအဲ့ဒါကြတော့ကွေးသွားတာကိုဖြစ်နိုင်တယ်တော်စင်လို့ဆိုတော့တော်ရှင်နဲ့လို့ဆိုတော့ဒါလိန်သွားတဲ့လိန်စေတဲ့ဝန်တွေဖြစ်တယ်တက်လို့ကတော့ဗါလဲဆိုရင်ပစ္စည်းကိရိယာတွေကဆိုရင်အသေးတတ်ထားတယ်နော်အဲ့ဒီတည်းမှာအမြဲတမ်းတတ်ရှင်ထားတယ်အဲ့ဒါဆိုရင်တက်လို့ခေါ်တယ် live လို့ဆိုတော့ဗါလဲဆိုရင်ဒီဝေးအဆောက်အဦထဲကိုလူတွေဝင်လာမယ်လူကဝင်လာမယ်ထွက်လာမယ်နောက်ပြီးတော့မှပစ္စည်းကိရိယာတွေခဏဝင်လာမယ်ထွက်လာမယ်အဲ့ဒါမျိုးကြတော့ live လို့ခေါ်တယ် impact လို့တော့ဗါလဲဆိုရင်တခြားဝန်တွေတက်ရောက်တာအဲ့လိုနော်ဝင်လာတဲ့ဝန်တွေကြောင့်မလို့နော်ပို့ပြီးဖြစ်ပေါ်လာတဲ့ဓာတ်တွေရာဆိုရင် impact လို့ခေါ်တယ်ဝင်လို့ကြတော့လေကြောင့်တက်ရောက်တဲ့အားဖြစ်တယ် snow လို့ကတော့ဗါလဲဆိုရင်နှင်းတွေကြောင့်တက်ရောက်တဲ့အားဖြစ်တယ် submissive လို့ဆိုတော့ဗါလဲဆိုရင်ငရင်လှုပ်တဲ့အတွက်တက်ရောက်တဲ့အားဖြစ်တယ်အဲ့ဒီလိုဝန်တွေရာဆိုရင်ဒီအဆောက်အအုံပေါ်မှာတက်ရောက်နေကြတာဖြစ်တယ်equation to calculate the load. So in this case, D plus L or the LR or S or R. In this case, and the D is a dead load, A is a live load due to either use for the equivalency. LI is a roof live loads, S is a snow load, R is a rain roofs. And also the next one with the D plus A plus W or E. Divided by 1 by 4, so that kind of the load. So in this case, D is a dead load, A is a live load, W is a wind load, and E is a submersive load divided by 1 by 4, that kind of the load. And 3 with a D plus A plus W plus S divided by 2. So D is a dead load, A is a live load due to the identity for occupancy, and S is a snow load. And also we also write down the D plus A plus S plus E divided by 1 by 4, or the 0.9 D minus E divided by 1 by 4. So those are the sub-kind of the loads. So you can also write down. အဲ့တော့ဒါပါလဲဆိုရင်ဝန်အားလုံးကိုတော့ပေါ်ပြထားဝန်အမျိုးမျိုးကိုပေါ်ပြထားဖြစ်တဲ့ဒီကတော့အသေးတင်ထားတဲ့ဝန်ဖြစ်တဲ့ air တော့ဒါရွေ့ရှားနေတဲ့ဝန်တွေဖြစ်တဲ့ air ဆိုရင်ဒီဝန်အမိုးပေါ်မှာနော်ရွေ့ရှားနေတဲ့ဝန်တွေဖြစ်တဲ့ S ကတော့နှင်းကြောင့်တက်ရောက်တဲ့ဝန်တွေဖြစ်တဲ့ R တော့မိုးကြောင့်တက်ရောက်တဲ့ဝန်ဖြစ်တဲ့ W ကတော့လေကြောင့်တက်ရောက်တဲ့ဝန်ဖြစ်ပြီးတော့ E က submersive လို့ဆိုတာငရင်ကြောင့်တက်ရောက်တဲ့ဝန်တွေဖြစ်တယ်ဒါကြောင့်မလို့အဲ့ဒီတက်ရောက်တဲ့ဝန်တွေကိုဘယ်လိုညီမချင်းနဲ့ရေးလို့ရဆိုရင် D plus A plus LR or S or R D plus A plus W or E divided by 1 by 4 D plus A plus W plus S divided by 2 D plus A plus S plus W by 2 D plus A plus S plus E divided by 1 by 4 နဲ့ 0.9 D minus E divided by 1 by 4ဆိုတဲ့ညီမချင်းနဲ့ရေးသားလို့ရမှာဖြစ်တယ်the diagram is simple beam, cantilever beam with the one end live and the fixed end beam, and the beam with the overhangs and the continuous beam. So that depending on the kind of the beam construction, we can classify either simple beam or cantilever beam or beam with the one end fixed or the fixed end beam or the beam with the overhangs or the continuous beam. Now, that about it, Yama is job today. Panama, figure 11 by 5 so now, you Yama today, simple beam today is 5 by 2ကြတော့ဗာလဲဆိုရင်အဲ့ဒါတော့ cantilever လဲလို့ခေါ်တယ်တစ်ဖက်ချုပ်လိုက်တစ်ဖက်ကလွတ်နေတာ5 by 13ကတော့နော် beam with the one end fixed တစ်ဖက်ကိုအသေးကိုနော် now the beam today at the doesn't other beam today, not to go we got 540 this and beam will call it. Never slow at the doesn't other beam today, figures are 515 out of beam with it over him. Napaka Asama swing, Napema alone, Tauta in the eye aloma, stay out in the wounded today, 516 of continuous beam. Sebio. Below paint the Kulo, below 1 year, said I tell you the beam today, and other years, beam Mumu, Yama Mumu, the young pity. When the weight are distributed on the bin, so that will also be the reaction force. So the example, there was an example of the reaction force, so there is a 50 feet long beam, so the 200 pound bar the inch feet, those are the low, so that the smooth are 36 feet apart, so that there will be the reaction force. Reaction force R1 can be calculated, the minus 2,000 multiplied by 40 plus 36 R1, minus 4,000 multiplied by 30, minus 6,000 multiplied by 18 plus 3,000 multiplied by 12, minus 200 multiplied by 60 multiplied by 18 equal to 0, so that from this way you calculate the R1 into 14,000. So this is for the reaction force. Now, Dima for the other one, so you won't count out when you see the element R1 and R2 who are to your Toma Tari. Now, they only the one the Yama swing the beach of the city at the Lama swing. They are bound over, are they only the 8 Tomatani and the Kua swing, don't let you be Guachani, but that you are 1 to 12, so minus 2,000 multiplied by 40 plus 36 hour, minus 4,000 multiplied by 30, minus 6,000 multiplied by 18 plus 3,000 multiplied by 12, minus 2,200 multiplied by 60 multiplied by 18 equal to 0, you like the swing, R1 14,000 pound, Yama Kitty. Shear diagram. The unbalanced external vertical force at the section is called the shear. When the unbalanced or the external vertical force at the section, this is called the shear. It is equal to the adjoining side of the force that lie on the either side of the section. So that will be our acting force on the left of the section are considered positive, and downward force are negative, and side are the reverse for the force on the right. A diagram which shear at every point along the length of the bin is plotted as an originator called a shear diagram. So in this case, you see the above diagram. This is a figure 5 by 19. The above diagram we say this is for the bin as a loading, and the bottom diagram is a shear diagram. The diagram is plotted starting from the left end. So do on the bound low was plotted downward, the convenience scale, and then the shear at the nasal concentrated low, and then the left support was determined, and then by this way whenever suppose shear will go upward, and when there is no support, then we shear will go downward. So that's the way the upward and downward force we can combine together, so that way we can plot the shear force diagram. And cool out about the swing now short art the short art so many things on it so applying they only the swing no they all can many things they all the art applying swing and a short art will call it. And a short art so the come as a boma swing a boy about the being or Yamapo, see the Yamapo when they only the outcast will not die, and a short eye can happen to it. And all stay out the one out one swing, the short art of Wame, and my Yamio Toma and I short art about the Rame. Now, no, the Toma and I look like I stay out the one you short art Dwame, a Dwale a bone sweat at us by the swing, she a wood diagram, call it, short art diagram, call it. The diagram of the surface component as a root truss. So that will be gimbals, or the Warren, or the English, or the Howie, or Pratt, or the Pratt, and Finks, and the bowstring. So those are surface types of the root trusses. The Maporta that Boa swing, to Amoya Madi, Bomio Pite. I must say gimbal see the Warren see the English see the Howie see the Pratt see the Fink see the bowstring see the Alabama swing, Tom Dan Yamadi, Bomio Swella to Yamachede. This is the foundation engineering. A foundation is divided as a bus on the structure that's for the weight of the structure and transfer the load to the underlying soil or the rock. So the foundation is for the structure and then transfer the load, the whole building load to the soil or rock. This is foundation. The foundation engineering applies the knowledge of the soil mechanics and the rock mechanics geology and structural engineering to the design and construction of the foundation for the buildings and the other structures. So the tools are understand the foundation engineering, so we have to apply the soil mechanics, rock mechanics, geology and structural engineering to the design, construction of the foundation for building and other structures. The most basic aspect of the foundation engineering deals with the selection of the type of the foundation site and the using shallow or the deep foundation system. So that we can either utilize the shallow or deep foundation system, we have to select the appropriate foundation system. Another important aspect of the foundation engineering involves the development of the design parameter. So in this case, the design parameter have to be developed, bearing capacity of the foundation, and foundation engineering could be include the accurate foundation design, such as determining the type of the spacing, the steel reinforcement in concrete footing. Those are included in the foundation engineering. Now, foundations are saying omye about the swing the omye as how we have one toma tabilo, a woman, Oka, Nizane, no Jody Bo, Pian your pian with other today. Yablo omye down lila de kama swing, no. Nijine patete, mechanic pinya, swine mechanic, no job in the patete, mechanic pinya, rock mechanic, Navio Bumi Vida pinya, Tisamu pinya, structural engineering, Eradio Naliame, Nale, no Cheladioma, Dilo foundation is decided Yama, don't be a machete. Now, a year check out of Valesui, Blue Foundation will learn UHM as what today, UHM the cover the foundation, not taking charmla, then the charmla, short amount D, and charmlas or HO, or Senzama today. And all. The foundation engineering young Yiji check out, the Ponga Bubo to lower the Cheladi or Topo Jimmy today. Umadi, the Nijia may be the Edo, Omidio Mata, so in the foundation of Mata, a Nijia, Man and the Blaushi, that's what people load it, and told to be the foundation, but the Omidio, to the Kamasui, a Chiga, not design Puloame, not the car, not below. Pero amusa o tamani o domale ay tamani dia zui the kunu blau kwa chamle the galo tangu concrete o domle kamale the kunu blau cha damle ay foundation ni no omit de kunu blau kwa cha damle အဲ့ဒီအချက်တွေသုံးရမယ်နောက်တစ်ခါ found ဒီ omit ကိုတိတ်တိမ်ချမလားနည်းနည်းချမလားရှော့လို့ချမလားတီးချမလားဆိုတာကိုလည်းစဉ်းစားရမှာဖြစ်တယ် Standard of penetration test. So this penetration test, we have to utilize the driving the tip water sampler into sand deposit, and it says that it's called the inside barrel 10 meter, 3 by 1 centimeter, and outside is a 5 by 0.8 centimeter. So sample taken, and then the SPD sampler driven the total of 45 centimeter, 18 inch with a number of blow recorded for the east 50 centimeter interval. So when you measure the name, we have to dry and how much of blow we go. Have to measure. So this is the measure SPD value blow bar feet. As defined by penetration resistance on the side. So we dry and every dry cell how much we given go through the sand have to be measured. So this is the blow bar feet dry have to be measured. So this is what is the standard of penetration test, SPD test. Now that who don't make clear about the same. Ye no pay a can I block she there block care better block going on as well. Time today, I'm a popular hard time SPD as we do a diameter to 3 by total much it is in the map in diameter. Not the matter is in the map. Allow Yay to be the Kaya than Yay, and below wind wireless or Dina in Pity. Hello, Dina in say a block Kuga she as well. Dina fishing in a Pity. On the boring law. So whenever we test as a sample, we try this bowl and then we can measure, we take the sample. So this is a sample of boring law. And here we will the substrate profile. So when you see the substrate structure, there will be all the content of the home water content, gray and also light gray, dark gray, and reddish, and this is the medium hard. Those are the substrate content. So those substrate content need to be tested before we bait them. Now, the for that, but let's say, hello, not that Yaya going your Sunday Kama, the Boya, your Sunday Kama, so I don't stand Yade, how much that today, not one about Popia, so in Nigie, how can ye die the South Pity, and may I below say by neighbor, make body so out, be South Pity. And I don't Nigie Ole, and below Ponga so people Lode, and I'm a little bit mad on it, she can be the one, and look in the sound like my pity. the bearing capacity analysis. Bearing capacity failure is defined as the foundation failure that's occurs when the shear strength in the soil is the shear strength on the soil. So the when there's a shear strength in the soil, so though when there's a we beat the bearing, so the bearings are stress are the inserted on the soil, so that this strength. This to the weight is greater than the strength of the soil, so foundation can be failure. So when the foundation failure can happen because the soil does not have the capacity, does not have the strength to lift the weight of the to support the leg of the bearing. In this case, there will shear can be the general shear. So general shear failure involves total rupture of the underlying soil. So that when the underlying soil to the rupture, there will be the general shear. This is the continuous shear failure of the soil from the below the footing to the ground surface. When the load is plotted versus the settlement of the footing, there is a distant load with the foundation to free. So this is for the general shear. The next one will be the punching shear. Punching shear will be the punching shear failure does not develop the distant shear surface associated with the general shear, but the punching shear is soil outside the load area remain relatively uninvolved. Only the something area, the starting area, the soil is punched, but around the other area, the soil in the other area does not involve. So this is the two kinds of shear happen. So this is the general shear and the punching shear. So in the diagram you see the diagram here when you put the load, so there will be internal surface, and also we draw the shear surface. So the shear load and the settlements you can draw in the graph. Who said you for Biama so in the now short and tari kid I saw we have one swing can near canning other poor water swing, I may swing short at town come kid. And all a short at town can come a swing, blue sheep mesro, the low not no. Jail da being yard come a swing, the outcome ye the Kulona, no, do can I out. Get you one at us in that general shear call it, Banjin shear jallo balesro, the low a no. Only Chara near the white baby near oh Joja Wada, Bede near the Asia Miriano, the I machine at a job Banjin Chialo call it. A general shear so not proper, so that is how you get one a Banjin Chiaro, Bena, Tauma, your beauty no yarn and a kid. Why is a retaining wall? So that we have to retain the structure of the wall, and on the side we can base a retaining wall. The retaining wall is defined as a structure whose primary purpose is to provide the lead transfer for the soil or the rock. So lead transfer on the right or the wall is provided. This is the retaining wall. So that can include the gravity wall, cantilever wall, and the counterfort walls and the crib wall. So those are the retaining wall. Those are retain the soil. The gravity retaining walls are routinely based on the plain concrete or stone, so we had to utilize the plain concrete or stone to base the gravity retaining wall. And the wall depends primarily on the massive weight to resist the failure from overturning and the sliding. So to prevent the overturning and sliding of the light and so on the ground, we had to utilize this retaining wall. So the counterfort walls consist of the footing, wall stump, and the intermittent vertical ridge. So call it this is the counterfort wall that ties the footing and the wall stump together. So that all the footing and the wall stump are together. That kind of the retaining wall is the counterfort wall. And crib wall consists of the interlocking concrete members that from sides which and faced with the compacted soil. So this is the construction of the crib wall. So in the diagram we can see that the common type of retaining wall, gravity wall is the figure A, and figure B is the cantilever walls, figure C the counterfort wall, and the crib wall E the symmetric gravity wall, and F is the bridge address. Those are the kind of the retaining walls that we show in the diagram. Who are about to maintain and they don't get their retaining walls and maintain and they immediately Pumajao, taking it, no, below Nayan, maintain and they will call it. Edimas in the gravity, no, below Meji, the sway out and the button of your, no, ခုခံထားတဲ့နိုင်ရန်ရှိတဲ့ cantilever wall တစ်ဖက်ကချုပ်ထားပြီးတစ်ဖက်ကပွင့်ဖြစ်တဲ့နောက်က counter foot wall နဲ့ clip wall တွေဖြစ်ကြတယ်။ cavity retaining wall ကတော့ဗာလဲဆိုရင်ဒီလိုသူတို့နော် concrete သို့မဟုတ်ကြောက်တုံးနဲ့တည်ဆောက်ထားတယ်။အဲ့ဒါဆိုရင်ဒီလိုနော်ဖုံတော့အတိအကျထုံမူတည်နေတယ်။အဲ့ဒါဆိုမြေကိုကရှော့မကြအောင်နော်ကာကွယ်လာတာဖြစ်တယ်။counter foot wall ကြတော့သူ့မှာဆိုရင်မြေကြီးအောက်မှာဆိုရင်ဘာလို့ခဏသူကပုံမြင့်လည်းပါတယ်။နောက်တစ်ခါအဲ့ဒီခါမှာဆိုရင်တစ်ခါတစ်ခုတက်ဆင်ထားတဲ့အစိပ်ပိုင်းတွေလည်းပါလာဖြစ်တယ်။ clip wall ကြတော့ဘာလဲဆိုရင်တစ်ခုနော်ကွန်တာ interlock လုပ်ထားတဲ့ပြန်ပြီးတော့ချိတ်ထားတဲ့ concrete တွေလည်းပါလာဖြစ်တယ်။အဲ့ဒါတွေကဆိုရင် retaining wall တွေဒါမြေထိန်းနိုင်နေဖြစ်တယ်။အဲ့တော့ပုံမှာဆိုရင်တော့မြေထိန်းနိုင်နေပြထားတဲ့ A ဟာဆိုရင် gravity wall ဖြစ်တယ်။ B ကတော့ cantilever wall C ကတော့ counter foot wall D က clip wall E ကဆိုရင် semi gravity wall F က bridge abutment တို့ဖြစ်တယ်။အဲ့ဒီပုံတွေဆိုရင်ဒါ retaining wall တို့မဟုတ်မြေသိမ်းနိုင်ရတဲ့အကြောင်းကိုတင်ပြထားခြင်းဖြစ်တယ်။ Also talking about the spread footing. The footing can be the spread footing, combined footing, or the straight footing. So the spread footing, combined footing, straight footing, so there will be the shallow foundation. They are probably the most common type of the bedding foundations. The next one is the mat foundation. The Isabel mount foundation is shown in the figure slide 41 based on the economic consideration. Mat foundations are constructed for the following reason. The firstly is we have to utilize is a less individual footing, so we have to utilize a mat foundation. A mat foundation is often constructed when the sum of the individual footings area exceeds the above the 1/2 of the foundation area. And B, cavities or the compressive lengths. A mat foundation can be used when the subsurface exploration indicates that there will be unequal settlement caused by the small cavities or the compressive lengths below the foundation. A mat foundation would bend to span over the cavities or the weak lengths and create the most uniform settlement condition. And C is a shallow settlement. A mat foundation can be recommended when the shallow sediments predominate and the mud foundation will minimize the differential sediments. And these are unequal distributions of the loads. The sand structures, there can be the large difference in the bedding loads adding on the different areas of the foundation. Conventional spread footings could be subjected to excessive differential settlement, but in the mat foundation would tend to distribute the unequal bedding loads and reduce the differential settlements. And E, hydrostatic uplift. When the foundation will be subjected to the hydrostatic uplift due to the high groundwater table, a mat foundation could be used to resist the uplift force. So this is for the kind of the footing and the foundation. So depending on the conditions, we have to utilize the appropriate kind of the foundation. အခုဒီမှာပေါ်ပြထားတာပါဆိုရင်ဒီအောက်ခြေတော့အုံမြင့်ချမယ်အနေထားတွေဖြစ်တယ်အဲ့တော့အုံမြင့်ချတဲ့အခါမှာဆိုရင်တော့ spread footing တို့မဟုတ် combined footing တို့ straight footing လို့ရှိတယ်အဲ့ဒါပါလဲဆိုရင်တော့အုံမြင့်ကိုတိမ်တိမ်ချတာတွေဖြစ်တယ်အဲ့တော့အဲ့ဒီတော့အုံမြင့်ကိုပေချတဲ့ဟာတွေဆိုရင် spread footing, combined footing, straight footing တို့ခေါ်တယ်နောက်တစ်ခုကတော့ mat foundation အုံမြင့်တွေကိုတစ်ခုဆက်နွယ်ပြီးတော့ကိုရက်လိုချထားခြင်းဒါအဲ့ဒါ mat foundation လို့ခေါ်တယ်အဲ့ဒါ mat foundation ချတဲ့အခါမှာကျွန်တော်ဘယ်လိုအချက်တွေနဲ့နော်ကိုက်ညီရမလဲဆိုရင်ဘယ်လိုအချက်လက်တွေအတွက် mat foundation ကိုချရမလဲဆိုတော့နော်တခုခုတော့ individual foundation ကိုချတဲ့အခါမှာဆိုရင်သိပြီး area သိပြီးတော့များနေတယ်နော်အဲ့ဒီများနေဆိုရင်အဲ့ဒီများနေတဲ့အခါမှာဆိုရင်စုပေါင်းနော်တခုနော်ဒီလိုချထားတဲ့ foundation area နော်စုပေါင်း foundation area ရဲ့နော်တဆခွဲတဲ့ပုံကြီးများတယ်ဆိုရင်အဲ့ဒါ mat foundation ကိုချရမယ်နောက်က cavity တို့မဟုတ် compressive length ဖြစ်နေတယ်အဲ့တော့နော် foundation ကို mat foundation ကိုနော်တခုအဲ့မြေကြီးအောက်မှာနော်တခုဟောပါလို့လေးဟာနေဖြစ်နေနော်ဂျားမှာ6တဲ့နေရာတွေရှိနေတယ်အဲ့ဒါဆိုရင်လည်းပဲဒီလို mat foundation ချရမယ်ဥပမာဒီမြေကြီးမှာနေရာနဲ့ဒီမြေကြီးက solid ကြောက်သားတွေဖြစ်တယ်ဟိုဘက်မြေကြီးကြတော့တခုအဲ့လိုကြောက်သားအပြည့်မရှိဘူးဆိုရင်အဲ့ဒါဆိုရင်ဒီလို mat foundation ချဖို့လိုအပ်တယ်နောက်တစ်ခုကတော့ foundation ကိုတင်ချဖို့ဆိုရင်လည်း shallow settlement ဆိုရင် foundation လိုအပ်တယ်နောက်တစ်ခုကဝုံဖြတ်တာမညီဘူးနော် unequal distribution တဲ့လို့အဲ့ဒီတစ်ခုလုံးမှာဆိုရင်ဒီနေရာကဝန်ကသိများတယ်ဟိုဘက်ကဝန်ကနည်းနေတယ်အဲ့တော့နော် foundation တစ်ခုရေးစီချရင်အဲ့ဒီ foundation ကနော်ဘယ်လိုပြောလဲအေးရကြုံကြသွားမယ်သိများနေတဲ့ဘက်ကဆိုရင်အေးရကြုံပြီးတော့အေးရခါကျိုးသွားနေတယ်အဲ့လိုမဖြစ်အောင်ဘုံမျှပြီးတော့ချခြင်းဒီဒါ mat foundation ကိုချမှာဖြစ်တယ် mat foundation တစ်ခုခုဆက်ပြီးတော့ချထားတဲ့နော် foundation တွေဖြစ်တယ်နော်သူကအဲ့ဒါကြောင့်မလို့ချတစ်ခုဆက်ထားတဲ့အုံးမြစ်တွေဖြစ်တယ်ဒါကြောင့်မို့ကြားတဲ့ဝန်တွေအကုန်လုံးကိုသူကညီမြခွဲဖြန့်သွားအောင်နော် mat foundation ကိုချမှာဖြစ်တယ်အဲနောက်တစ်ခုကတော့ hydrostatic ability အောက်စာမြေကားမှာဆိုရင်ရေတို့ပါလို့ရှိနေမယ်အဲ့ ground water ဆိုတာမြေအောက်ရေအောက်မြေရှိတဲ့စကားမှာဆိုပဲအဲ့မှာအဲ့မြေရဆိုရင်အဲ့ချတဲ့ foundation ကိုပြန်ပြီးတော့ကန်ထားမယ်အဲ့လိုကန်ထားတဲ့ဆိုရင်တော့တနေရာရဲ့တရားမညီမျှဘူးဖြစ်နေလိမ့်မယ်အဲ့လိုညီမျှသွားအောင်ဒါ mat foundation ကိုချမှာဖြစ်တယ်I can show this an example of the mat foundation. So all the foundation that you see there, you are mat, they are joined together. So that way, A is a flat plate, B with a plate thickens under the columns, and C the beam slab, and D the plate with the balustrade, and the C is a basement wall as part of the mat. So those are the kind of the mat foundation. Now, so in mat foundation, a foundation to do set up mat foundation will call it. A mat foundation charm. So there will be we have to put a pie. So this is the kind of the pie. So there will be the advantage of the pie. So sometimes we have to put the pie. So to make the retaining. So there will be the kind of the pie and the characteristic. Now, aku di mana popular dah so in the pie ni, jangan kita pie ni so in pie ni jadi do miu lah, tiang bolu ada, ada so in di pie ni miu sah ni tu doa, cuba jadi jangan popular dah jadi. The grade of the steel. When we construct this building, we also have to utilize the steel. So there are structure the grade steel. Structure the grade steel are the fast by the corresponding ASTM the designation. For the most commonly used the grade of the structure steel A36, which produced to meet the requirement of the ASTM the A36 specification. So this is for the structure steel. So they are kind of the structure steel, their application, their thickness, and they are stressed. You can see in this diagram, this table. အခုပေါ်ပြတာတော့ပါဆိုရင်ဒီဆောက်မှုမှာအသုံးပြုတဲ့တာမဏိတွေအကြောင်းဖြစ်တယ်အဲ့တော့ဒီဆောက်မှုမှာသုံးတဲ့တာမဏိတွေကျတော့ ASTM standard နဲ့ပြုလုပ်တာဖြစ်တယ်အများဆုံးသုံးတာတော့ A36 တော့ steel မျိုးစားကိုအသုံးပြုတာဖြစ်တယ်ဒီပုံမှာဆိုရင်သုံးပြုတဲ့ဟောဒီလိုဒီဆောက်မှုတာမဏိတွေအကြောင်းသူတို့ရဲ့အထူတွေသူတို့အတိုင်းအတာတွေသူတို့ကခံနိုင်တဲ့ဓာတ်တွေကိုအသေးစိတ်ပေါ်ပြတာလားအဲ့ဒီဇာတ်မှာတွေ့ရမှာဖြစ်တယ် fastener. So the fasteners are one in the building, one the gather all the building material need to be the fastened together. So we have to utilize a bolt and a nut to the fasten the building's equipment. Two basic types of the fasteners are typically used in the construction, bolt and west. Both are used in the fabrication, the shore and on the job site, in the connection joining individual members. Welds are also used to fasten together the components of the bed and members. Bolts, however, are more commonly used for the field connections, and the welds for the shore work, rivets, which most are widely used for the connection, and the both shore and the field are essentially obsolete. So this is the kind of the fastener. So far the fasteners are the economy of the fabrication, the erection, ability of the equipment, especially in criteria, labor. So those are also those factors are the contribute the application of the fastener. Now, ပေါ်ပြမှာတော့တုံးတူတွဲပြီးတက်စင်တဲ့ကိရိယာတွေဖြစ်တယ်အဲဒီတွဲစင်ကတ်စင်တဲ့ကိရိယာတွေကဆိုရင်ဘိုးတွေနတ်တွေလည်းသုံးတယ်နောက်ကြီးရှည်စော်ပြီးတော့လည်းသုံးတယ်အဲ့တော့ဒီလိုစောက်လုပ်ရင်းမှာစေတံပြားတွေတစ်ခုနဲ့တစ်ခုဆက်ဆက်ဖို့တန်ရက်မတွေတစ်ခုဆက်ဆက်ဖို့ဆိုရင်အဲဒီလိုဘိုးတွေနတ်တွေလည်းသုံးတယ်ကြီးစော်ပြီးတော့လည်းသုံးတယ်အဲ့ဒီမှာဆိုရင်ဘိုးတွေကဆိုရင်လည်းများအသုံးပြုနေတာဖြစ်တယ်အဲ့တော့အဲ့ fastener တွေကဆိုရင်တော့အသုံးပြုခြင်းအပြင်တော့ဒီလိုတော့စီးပွားရေးနီးကြတဲ့သူတို့ fabricate လုပ်လို့ရတယ်ဒီဆောက်လို့ရနိုင်တာဖြစ်တယ်အဲ့ဒါဆိုရင်ဒီပုံမှာဖော်ပြထားတာဆိုရင်အဲ့ဒီတော့ fastener တွေအကြောင်းကိုဖော်ပြထားခြင်းဖြစ်တယ် The welding is used to fasten together components in the bed and members such as a plate gather to make the connection between the members. So welding is used to utilize to connect the members. This technique we use a fusion is a control atmosphere requires a more highly skilled labor than the task boarding. So the welding case the weather is a space labor. Boardings are the ordinary labor can make the boat. However, because the cost advantage within the widely used in the steel construction, especially the steel construction, we utilize the welding, especially in the fabricated shop, where the conditions are more favorable to closely control the procedure. So that inside the fabrication shops, we utilize the welding. When the field welding is specified, the availability of the skilled welders and inspection techniques and the use of the more stringent quality control criteria should be considered. So that when we are utilize the welding fee, so in this case, skilled labor is required and appropriate inspection technician will also be required. So also quality control criteria also has to be considered. This is for the welding. And who probably man of key set up the key set up swing. Now Yamadi who lose a set at the hardy, not Dami than John who set at the Kama swing, not get set up so army. And all, not both set out or you leave on in Seluyade, you allow the ma. Not Tabime, not get his set at Jalo, joining the geese for the ma, he set the man Luana Tide. And all. Dabimelo Adiro gay set Yasi, and now you Koyamu Mushide, Yamro gay set Yale. Now the car, they said us when fabricating short and watch out the Malagi Seluyale. And I may Eddie gay set out Solo Saima, Tobi gay set as way, joining the Lulu, and a set out Mamma Santa Bule Lule, told to bed, no, a year with San Sede, Senate and what I did. This is the application of the trust application. So you see the cross section through a number of the bedding, having the root truss. They are also discussed, so that you see that how the truss are applied in the bedding. Now, Dima Popia about us in the trust view, no, don't do that today, Yamari, don't do that today, a beda bunchi, the Kama swing, a Yamari, to lead the Saunama, the Lugona as well, to Yamate. It's a brazen the door bedding. So if the steel frame or the multi-story bedding, so they're subject to the literal window, it will distort as shown in the figure. So all the if the connection pins are the standard die, so which are rigidly resistant to the rotation is knee. So we have to utilize the all the you see the bedding. So if you see the A, so if you only make the construction in A, so it can be because the wind load, it can be distorted in showing the B. So you have to utilize the C. So this is the wind bracing has to be applied. So this is the multi-besa wind bracing diagram for the multi-story bedding. Now, who's the Mapobia about the swing, the highlight bedding, the mass swing, not to do my set with Hade, to do, no? The Tan Yamadi, Tan Yami Pompoda, she there, Clear Tele swing, no, Ema Dango, Clear B Dango, someone and the Elma, someone and the C Dango, Piambio, no, Leo Piami Kukan Tabu Luade, wind bracing no correct. So this is what a bridge based in a one-story bedding. So you can transmit the wind loads to the ground. So that all the wind loads are all the bracing are we going to join together. So all the intermediate bedding. So this is the ridges are straps. They join together like this. So that way all wind loads can be transmitted to the ground. Now the Mapobia about the swing a one-story bedding. I must swing later of the Kama swing. Job the Leo. I must set the bracing and the same you no. To child below being